So in this video, I want to share with you some of the advice I have for the 2020 AP Physics 1 exam. So the first thing I would really recommend this year is make sure you have all of your materials handy. You should have your calculator. Along with your calculator, I'd make sure you either have fresh batteries or a charger handy. If your calculator starts to die in the middle of the exam, you don't want to waste a couple of minutes digging for where you put your charger and then finding a place to plug it in. If it's just right there ready to go, you're going to be much better off. You should also make sure you have access to your equation sheet. You can use the purple version I handed out earlier this year. You can print out a copy from Schoology, or you can use a digital version. Now, if you use a digital version, I would strongly recommend downloading that in advance. If your internet starts to have trouble in the middle of the test, right as you need an equation, you don't want to have to waste time troubleshooting to be able to look up a formula you need. By the same token, you should make sure your notes are handy. If they're in some kind of digital format, so if you made any notes you're going to use on a computer or download or are looking at files that I posted to Schoology or from a website, you should make sure those are saved to your computer or to your phone, somewhere where you don't have to worry about your internet slowing down to pull those up. It would also work just fine to have them written down by hand in a notebook or to have printed them out in advance if you have access to a printer. The last thing I'd make sure you have handy is a ruler or a straight edge. Now, I realize not everybody has a ruler at home, and there's pretty much never anything you need to actually measure on the exam. More what the ruler is used for is drawing straight lines. And so if you have something like, I often use notebooks or I use IDs, things like that. Anything that you can use to draw a nice straight line. You may not need that, but it'll be nice to have if it comes up on this year's exam. And then just like with any other test, you should make sure you have writing utensils handy. So pens, pencils, things like that, and even have a backup or two right there so you don't have to go digging if your pencil breaks. Now, when you're approaching the problems, the first question you should always ask yourself is what models apply to this problem? And that's going to essentially remind you which toolkit do you need to look in to figure out this problem. In general, if you can use the energy transfer model, or ETM, you should. That is always my first choice for solving problems because very often, energy is going to be the simplest way to solve a problem. Now, if you have a collision, that's the one case where I don't go to energy first. I go straight to momentum transfer for anything that involves two or more objects colliding with each other or bouncing off each other or exploding off each other. The reason I do that is if the collision is elastic, that means there's no dissipated energy. And so both energy transfer and momentum transfer are going to work to solve the problem. However, if the collision is inelastic, that means we do have some e-dis, which is really challenging, if not impossible, to account for. But momentum transfer still works. So whether the collision's elastic or inelastic, momentum transfer works, but energy transfer only works if the collision's elastic. And typically, even if you have to answer something about whether it's elastic or inelastic, that's worth very few points compared to things that involve diagrams or problems or reasoning. And so if you guess wrong on whether it's elastic or inelastic, if you're using momentum transfer, you can still get to the correct answer. And then as a reminder, we do have other models you can use. We have the constant acceleration of a particle model. We have the force on a particle model. We have the oscillating particle model, though typically if you use that one on the AP exam, it's going to involve using pieces from other models, things like LOL diagrams or free body diagrams. And then we also have the angular motion model, the central net force model, and the force on an extended body model. Now, once you've thought through which model or models apply to the problem, make sure you're using those tools. Even if you're pretty confident you have an answer to what's being asked, take the time to sketch a diagram or two. That's often a way to just double check that you're on the right track. And I do frequently see students have an initial answer that is not correct. But once they sketch some diagrams, they're able to add what's missing to their original answer to get to the correct one. Now, if you're stuck, that is especially a time to sketch diagrams, even if you're not sure how you're going to use them. A lot of times, if you start sketching diagrams and you start jotting down equations and other key ideas from the relevant model, you're going to eventually see a route to be able to solve that problem. So, go ahead and start with sketching diagrams and jotting down key information. Try to do that instead of just staring confused at a problem that you are stuck on, and that's often going to lead to some progress, even if you don't see where it's going to lead right away. Next thing is to make sure you read carefully. So once you have your answer written down, just double check. Did you answer the question that they actually asked? Make sure you're not just writing down beautiful physics. Make sure you're writing down beautiful physics that answers their question. If they provided diagrams, did you make any use of those? Did you reference them in your answer? Did you use them in your reasoning? I often see students get questions wrong because they ignored information that was in the diagrams that showed up in the problem. So don't ignore those. They give them to you for a reason. And then the last piece of advice I have related to reading is add annotations to diagrams that you've sketched or that they've provided. And as they oftentimes have these big blocks of paragraphs that are really, really densely packed with information. And so as you add information from that paragraph to a diagram, go ahead and cross it out in the paragraph. That's going to help you focus on what is the key information you really need to think about. And a lot of times you can essentially get rid of most of that paragraph by the time you finish reading and annotating any diagrams you have. Now, some advice specific to the paragraph response. This is going to be the 15-minute problem. The claim evidence reasoning structure works really, really well as a way to format your answer. Now, I would recommend writing the claim last. And so leave some space right below the question, and then start working on the evidence and the reasoning. And then at the end, once you're ready to write an answer, go back and write that in the blank space. That's going to make it easy for the reader to identify what is your answer, but you'll have done this really, really good thinking to figure out what that answer needs to be. So, in terms of timing, do your evidence and your reasoning first, but make sure that the claim shows up first on your paper. For the evidence, use diagrams and equations. So what I recommend is start by sketching those diagrams from whatever model you've decided applies, jot down some of those equations from the model that applies, and then for your reasoning, you're going to put into words what those diagrams and equations are telling you about this scenario. So make use of those tools from the model. Now for the qualitative-quantitative translation, this is going to be the 25-minute long problem. One thing to really pay attention to is whether they are asking you to use a certain model. It's really, really common on this type of problem that they'll ask you to think about a scenario in a few different ways. So if they ask you to give your answer using energy, make sure you're using energy bar charts and you're using the energy equations and things like that to reason out your answer. If they ask you to justify your reasoning using forces, then you need to make sure that things like free body diagrams and equations for the different types of forces are shaping your thinking. So pay attention to when they ask you to approach it a certain way. If they ask you to think about a question in a certain way and you have the right answer, but don't use the approach they asked for, you're going to get very, very few or even 0 points. And then the other thing to pay attention to is they'll often ask you to reason with an equation, and they'll ask you to reason without equations. So pay attention to how they're asking you to approach it. If they ask you to reason from the equation, make sure you pull whatever equation is relevant, whether it's one that shows up in the problem, whether it's one that they had you derive, or whether it's something from your formula sheet. And make sure all of your justification comes from that equation. If they ask you to reason without using the equation, try to get that as far off to the side of your brain as you can. Use diagrams, use graphs, use other tools to get to your answer so that you're not only answering the question, you're answering it in the way they've asked you to.